Alright, so let's see what we have. We have factor the sum or difference of cubes. So we have 3 examples to do. And we're just gonna do it with some of these formulas, these special product formulas, I believe they're called. So we have number 1, 27x to the third power minus 8. So we're gonna have to use the difference of cube formula for this one, which is going to be u raised to the third power minus v raised to the third power, kind of like we have in this format, is equal to u minus v multiplied by u squared plus u times v plus v squared, right? So this is the formula that we're going to use to factor this. So let's go ahead and find out what our u in this polynomial is. So u, we need to find what u is. Notice that this is in u to the raised to the third power. This is u raised to the third power, right? So we only want to find u. In this case, we will take the cubic root, the cube root of this this term right here, 27x to raised to the third power. So what by itself will give us 27? What multiplied by itself 3 times will give us 27x to the third power, right? That is going to be 3x, right? 3x. Because 3x times 3x times 3x is going to give us 27x to the third power. So that's going to be your u. Let's find our v, which is basically the same thing. What by itself 3 times, well, multiplied by itself 3 times will give us 8. In this case, let's just ignore the negative right now. But what multiplied by itself basically 3 times will give us 8. It's going to be 2, right? 2 times 2 times 2 is 8. So now we can go ahead and plug these values into our formula. So we have u, which is 3x, minus v, which is 2. U squared, which is 3x, raise that to the second power. That's 9x squared, right? Plus u times v, 2 times 3x is going to give us 6x. Plus v squared, 2 squared, that's 4. Right? So we have 3x minus 2 multiplied by 9x squared plus 6x plus 4. So that looks like it's going to be our answer. So that is how we're going to factor this one out. Let's go on to the second one. T raised to the third power plus 1. This is a sum of cubes, so we're going to use the sum of cube formula, which is u raised to the third power plus v raised to the third power equals, what does it equal? Equals u plus v, right? U plus v multiplied by u squared minus u v plus v squared, right? Plus v squared. So that's our formula. So let's go ahead and define our u and v terms. So let's go ahead and, what does u equal? The cube root of t raised to the third power is just t, right? Because t times t times t is going to give us t raised to the third power, right? So let's go ahead and find out our v. V is just 1, right? The cube root of 1, any root of 1 is 1, right? So 1 times 1 times 1 is going to give us 1, see? The root of whatever root of 1 is always going to be 1. So let's go ahead and plug our values into the formula. So u is t plus 1. U squared is t squared minus u times v, 1 times t is just going to give us t, right? Plus 1 squared, 1 times 1 is just going to give us 1, right? So we have t plus 1 times t to the raised to the second power minus t plus 1, right? That's going to be our answer for this one. Just like that. So let's go ahead and move on to the third one, the last one, x plus 2 raised to the third power minus y raised to the third power. All right, let's go ahead, and this is a difference of cubes, so we're going to use this exact same formula, but for this one. So we have u raised to the third minus v raised to the third is going to equal to u minus v, right? Minus v u squared plus uv, u times v plus v squared, right? So that is going to be the same formula we use for that one. So let's go ahead and define our u and our v. Our u, the cube root of x plus 2, all of this parentheses, is going to be just x plus 2, right? Let's keep the parentheses in there though. Yeah, let's just keep the parentheses. And then v is going to be the cube root of y. Ignore the minus sign for right now, but the cube root of y is just going to be y, right? Y times y times y is going to be y to raise to the third power, right? So let's go ahead and plug in our values into the formula. So we have u minus v, which is x plus 2 minus v, which is y. Let's put that in brackets, multiplied by let's see, x plus 2 minus y, right? That's what we got. Multiplied by u squared, which is x plus 2 raised to the second power, right? Plus u times v, which is u is x plus 2, right? Our v is going to be y, so you multiply that by y. Plus v squared, y times y is just y squared, right? So now we have that. Let's go ahead and basically just use a distributive property and basically just multiply what needs to be multiplied, so we can basically, let's just do that so we can like kind of expand this thing. So we have x plus 2. Let's remove the parentheses because nothing is being multiplied here. So it's just x plus 2 minus y. We can't really combine anything here, so we're just going to leave that as that. So this is going to be x plus 2 raised to the second power. Let's go ahead and multiply that one. So we have x plus 2 multiplied by x plus 2. Let's go ahead and multiply it. So x times x, that's x squared. 2 times x, that's 2x. 2 times x, again, that's 2x. 2 times 2, that's 4. So this is going to give us x to the second power plus 2x plus 2x, that's 4x, plus 4x, plus our constant 4. And now let's go ahead and use a distributive property to distribute this. So y times x, that's x plus x times y, that's xy. Y times x, xy. Y times 2, that's 2y, plus y to the squared. Let's see, x squared plus 4x plus 4 plus xy plus 2y plus y squared. We can't really combine anything here, so this is about as much as we can simplify this thing. So this can be your answer. So that is basically it for the sum and the difference of cubes. So yeah, that's it. Pretty easy.